What happens when a star dies? A cosmic titan collapsing under its own weight. Imagine a giant star, a celestial being many times larger than our sun. It has shone brightly for millions, even billions of years, but its fuel, the very source of its power, is dwindling. The star, once a beacon of cosmic energy, is approaching its final act. Death, even for a star, is a dramatic affair. It's a celestial ballet of epic proportions, a cosmic drama played out over eons. But stars don't simply fade away. They explode, they collapse, they transform. Their death throes echo through the universe, shaping the cosmos as we know it. The death of a star is a reminder of the constant cycle of creation and destruction in the universe. It's a humbling thought, knowing that even these celestial giants, these seemingly eternal points of light, have a finite lifespan. But when a star dies, is that the end? And where do stars even come from? Actually, after a star's death, the very atoms that made up these stellar behemoths, scattered across the vast expanse of space, will one day coalesce to ignite a new generation of stars, a beautiful cosmic cycle of life, death, and rebirth. Stars are born in the cold, dark depths of space, within immense clouds of gas and dust known as nebulae, where gravity, the architect of the cosmos, draws these particles together. Slowly, over millions of years, the cloud collapses under its own weight, and as the cloud contracts, it heats up. The core, where the density is highest, becomes incredibly hot and eventually reach a critical point. Under this immense pressure and astronomically high temperatures, hydrogen atoms, the simplest and most abundant element in the universe, are forced to fuse together, creating helium and releasing an immense amount of energy. A star is born. For millions or billions of years, the star exists in a state of equilibrium, where the outward pressure from nuclear fusion in the core balances the inward pull of gravity. This delicate balance defines a star's life, determining its size, temperature, and ultimately, its fate. Not all stars are created equal, though. Some are massive, burning brightly and living relatively short lives. Others are small and faint, sipping their fuel slowly over billions of years. But regardless of their size or lifespan, all stars share a common origin. They are born from the ashes of dead stars, forged in the heart of a nebula. A star's lifeblood is its fuel, hydrogen. This element is the key to the nuclear fusion reactions that power these celestial giants. But even the vast reserves of hydrogen within a star are finite. As a star ages, it gradually exhausts its hydrogen fuel, and the depletion of hydrogen marks a turning point in a star's life. The outward pressure from fusion weakens, allowing gravity to gain the upper hand. Therefore, the core condenses, heating up further. This triggers a new wave of fusion, this time fusing helium into heavier elements like carbon and oxygen. Then the star enters a new phase of its life, expanding outwards as its core contracts, and it becomes a red giant, a bloated, luminous star nearing the end of its days. For stars like our Sun, this is the beginning of the end. They will eventually shed their outer layers, leaving behind a dense white dwarf star. But for more massive stars, the story doesn't end there. They continue to fuse heavier and heavier elements in their cores, from carbon to neon, oxygen to silicon. This process culminates in the production of iron, and iron is the death knell of a star. Unlike the fusion of lighter elements, which releases energy, fusing iron requires energy. Essentially, the star is now living on borrowed time. The death of a star is not a singular event, but rather a spectrum of possibilities, each more dramatic than the last. The fate of a star hinges on its mass, which dictates how it will meet its end. For example, smaller stars like our Sun face a relatively gentle demise. As they exhaust their fuel, they puff up into red giants, shedding their outer layers into space. What remains is a white dwarf, a dense, Earth-sized ember that will slowly cool over billions of years. Whereas, medium-sized stars, several times more massive than our Sun, meet a more violent end. They too expand into red giants, but their cores collapse more rapidly, triggering a supernova explosion. For a brief shining moment, these stars outshine entire galaxies, and the remnants of such explosions can linger for thousands of years, enriching the surrounding space with heavy elements. As for the most massive stars, those over 8 times the mass of our Sun, they are destined to become either neutron stars or black holes. Their cores collapse so rapidly and violently that they implode, creating the densest objects in the universe. Supernova remnants, the expanding clouds of gas and dust left behind by supernova explosions, are stellar nurseries, seeding the cosmos with the building blocks of planets and life. These remnants are rich in heavy elements, forged in the heart of dying stars and scattered across the universe. Neutron stars, the incredibly dense remnants of collapsed stellar cores, spin rapidly, emitting beams of radiation that sweep across the cosmos like lighthouses. These pulsars, as they are known, are some of the most precise clocks in the universe, offering insights into extreme physics and the nature of gravity. Black holes, the most enigmatic objects in the universe, are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are the ultimate cosmic abysses, warping the fabric of space and time. Their existence was once a theoretical curiosity, but now it's supported by a growing body of observational evidence. The study of stellar death offers a glimpse into the vastness of the cosmos, revealing the intricate life cycle of stars and their profound influence on the universe we inhabit. It is a testament to the power of science to unravel the mysteries of the universe, from the birth of stars to their dramatic and awe-inspiring demise. Please like and subscribe. Thank you for watching.